Hello everybody, this is lesson 10.5. This is basically adding, subtracting, and multiplying radicals. So please print out the notes from Play-Doh and follow along. So when you're adding and subtracting radicals, you have to think about if they are like radicals. So in order for them to be like radicals, they have to have the same indices and the same radicands. So what does that mean? That means if you have this and this, they are the same. They're like radicals. They have the same indices and the same radicands. But if I change one of those things, this or this, they will not be like radicals. They have to have the same indices and the same radicands. So it's asking if these are examples of like radicals. So these have the same indices. On a square root, the index is a 2. But the radicands are different, 3 and 5. So no, they are not the same. Let's look at these. These have the same indices. They're square roots, and on a square root, the index is 2, and the radicand is also the same. They're both 2. So yes, they are like radicals. Let's see, these actually have different indices. This is a cube root, and that's a square root. So the index there is a 2, and here it's a 3. So no, they are not the same. Even though the radicands are the same, the indices and the radicands, excuse me, both have to be the same. And then this one, indices are the same, but radicands are different. So no. So this is for adding and subtracting. They always have to be same indices, same radicands, and those are considered to be like radicals. So when you're combining them, if you look at this, what this shows you is why combining like terms works, basically. So what they're showing you is if these both have a root 2 in common, you could factor out the root 2 from both of them. So this is factoring out the root 2. So if you take away the root 2 there, what's left is 8. And if you take away the root 2 there, what's left is 3. And so now you can just combine those two and you get 11. So it's 11 root 2 is your answer. Okay, and that's just to show you that if you have those, you can add the numbers in front and just keep the radical piece the same. So it wants you to verify on the calculator. So here's how you would verify on the calculator. The problem was 8 root 2 plus 3 root 2. So here it is. Oh, blah, forget that. Come out of the radical. Okay, so there's that problem. And then it wants you to see the answer we got was 11 root 2. So is 11 root 2 the same? Let's try and get it this time. It is. So that verifies the answer. That's using the calculator. In the next ones, I think, well, you have to verify on the calculator in the section after this. So simplify by combining like radical terms. So these are alike because remember they have same indices, same radicands. So you can add the numbers in front and keep the radical piece the same. So this is just 6 root 7. Okay. This one, those are like radicals because they have the same index 3 and same radicand 2. So you can just subtract the numbers in front and keep the radical piece the same. So 8 times the cube root of 2. They are like radicals. The indices are the same. They're both 4. And the radicands are the same. They're both x. So you can subtract the numbers in front. I'm saying subtract because it's minus there. So it's 6 times the 4th root of x. And then this one. Okay, so you have to look for your like terms in here. So these are the like terms, and these are the like terms. So you're going to have 5 root 7 plus root 7, and I'm getting that from the plus in front of there. So you get 6 root 7 because there's an implied 1 out here. And then here you have negative 8 times the cube root of 11 plus 9 times the cube root of 11. I'm getting the sign from here and here. So it's 1 cube root of 11. And you can have the 1 there or not. It does not matter. That one. Okay, so we're combining still here. We can verify it on the calculator. If you look at these are not like radicals because they don't have the same radicand, but you can simplify this one. So there's an extra step here, and the extra step is that a lot of these you have to simplify before you can actually do the problem. So remember, when you simplify this, you're looking for the largest perfect square in there. So root 8 is root 4 times root 2. You have that 3 out in front. So root 4 is 2. So you have 3 times 2 times root 2. So it's 6 root 2, multiply those, minus 5 root 2. So you're doing 6 minus 5 and keeping the radical piece the same. So it's just 1 root 2 or root 2 because the 1 is implied. Okay, both of those you have to simplify. So remember, biggest perfect square. And actually, I'm going to do it here too. So root 9 times root 3. So this is 5 times 2 times root 3, which is 10 root 3. This is 16 times 3 times root 3. So it's 48 root 3. You have to multiply them. Add those, it's 58 root 3. And when you're simplifying these, if you don't get down to where the radicals are the same, I would be a little suspicious. Let me go back to that one. This one, let's see. Okay, so these are cube roots. So remember how you simplify these. You are looking for groups of 3 things in here. So the cube root of 27, you can break it down into its prime factorization if you want. So it's 9 times 3 and then 3 times 3 here. And so the prime factorization is 3 times 3 times 3. So the cube root of 27 is just 3 because you have 3 3's there, and you're looking for groups of 3 because the index is 3. Okay? And the cube root of 8, the prime factorization is 2 times 2 times 2. The cube root of 8 is actually just 2 because there's one group of 3 2's. So you have to take, it looks like this. The cube root of 8 is 2. So the problem you're doing is 3 minus 10. So it's just negative 7. Probably a lot of you could have done these without looking at the prime factorization. A lot of you probably already know that the cube root of 27 is 3 and the cube root of 8 is 2. And then lastly, and actually I think I'll verify this one on the calculator because I haven't done any of these yet. So simplify that thing, look for the largest perfect square, so it's 25. So you have 9 times 5 times root 2. This cannot be simplified. So you get 45 root 2 minus 4 root 2. So it's 41 root 2. Okay, so let's verify this one on the calculator because we haven't done any of these and we should have been doing all of them. So I'm going to type in the original problem. Okay, so there's the original problem. Okay, and then let's type in the answer. We got 41 root 2. Oops, there it is, same answer. So we're doing it correctly. Take care, everybody. The back page will be in the second video.